due to current events and the break from school, of course, things have changed. Obviously, we're going to be deep into control assessment by this point, and which is what we've been gearing up to all through the year with Visual Basic and so on. But we'll return to that in due course, and no one will be penalised because of that. So it gives an opportunity to dip into some of Unit 1 theory. You'll have noticed on your class stream that's a 10C, there's also a 10D, this is also a 10D stream, which is exactly the same for others. Well, you're obviously in it because you're watching the video. On the stream, it's got some new information that's come up today. Now, you can click on these if you want to, but there's no need on the stream. Go into the classwork section, and there's a hardware section. So we're going to be doing Unit 1 of the theory work. If I go to the specification textbook area, these are just resources for you to access. So here's the specification first of all. If I open that, zoom down, and it's got the 3 units, Unit 1 Understanding Computer Science, that's an hour, that's an examination. There's software development, the non-exam assessment, which is the control assessment, and there's a practical exam as well. If we scroll down, here's some of the, if we just scroll through to the content, here we are. So Unit 1, hardware, and we're going to go through all of this. It's worth referring to this just to see, but in essence, what makes up a computer, input-output devices, which we looked at when we did we did the family, the Jones family scenario back in year 9. Also storage, different types of memory, and then also where computers and so on are used, as well as expandable items. Some of their units we will skip over. These are best done in a classroom situation, but networks we'll probably go into if we need to during this long break. There's a textbook. The 2019 textbook is from the WJC, and this is a very good one, and the examiner for the unit is there, so a lot of this information is going to be what's expected in the exam. So Unit 1 is hardware. You'll need to read through this in order to look at the notes, but if you look at the images, these images we use in the presentations, which I'll show you now in just a moment. So it talks about von Neumann. John von Neumann was a mathematician, but then a computer science scientist who came up with the structure of there being inputs, processes and outputs. So input devices, a process occurs, something, a verb, a doing word happens to it. Either it's added, it's edited, it's searched, it's taken away, it's multiplied, whatever it happens to be. And then an output is performed, whether that be to an output device, a monitor, printer, or some other device, or some other part of the internal workings of the computer, such as going from one register to another. You've seen these sort of things, the registers, when you did the assembly language work. If I go to our classwork here, if I go to, you did this before Easter, if I scroll down through hardware, and you'll see assembly language, and where we did the assembly language work using the Little Man computer, and we saw the information data pass into certain registers, really just storage locations in the random access memory or in the cache or other parts of memory inside the computer. If I just open up the theory book, and it talks about all those registers, and all these components have their own specific function. Of course they do. ALU, arithmetic logic unit, arithmetic's telling me that it's going to add or subtract. So it does that. The controller decides what goes on. So it controls which part of processing is going to happen next. Internal cache memory, very close to the processor. So it can be accessed. The RAM would be situated a little further away, so it takes a little bit of time for information to pass to and from the random access memory, although it's very fast. But the internal memory, the cache, small amount of memory, but it's very fast because it's right on the processor itself. So similar to, do you want to go and get your packet of crisps from the Spar around the corner, or go the other side of town? Well, obviously you're going to go to the Spar around the corner because it's a lot closer. So you get back with that packet of crisps, let's call that data, you get back with that data a lot faster. It talks about each of those components here below that. There's a nice von Neumann structure here: input devices, the processor, and output devices. And I also to add memory, that's random access memory, and also secondary memory as well, such as CD drives, DVDs, external hard drives, the onboard hard drive, which isn't part of this, but it's in this area here, which is memory, the hard disk. It talks about buses. You saw buses, about data passing along the registers from one memory location to another. So there's an address bus that carries the addresses, so maybe memory location 99, and the data that comes with that is the number that's stored in that register, and the control bus decides which signal and which command is going to happen next, okay, and whether it's a write or a read and so on. All right. It talks about something about the fetch execute cycle, which you can have a read through. It's really just fetching some information, decoding it, and find out what it understand what it means by that command, and then perform that operation. Then goes to fetch the next one, then decode, and so on. Right. Throughout this, you'll see some terms and so on, and by all means, obviously, write to me or email, but I'll cover this in future short videos. It'll be shorter than this particular one, although I'm going to keep this fairly short so that you can get on with the tasks. Talks about single core and dual core and quad core processors, and there's some good animations for you to look at. Talks about complex and reduced. So this is instruction set. RISC is reduced instruction set, and CISC is the complex instruction set. The fact that reduced instruction set is a lot faster and is the newer way to do it, and it talks about the two types of processors and the amount of power that's required for a complex instruction set and so on. All right, and then the benefits and drawbacks of each. Complex process and complex instructions, how it requires more circuitry to decode, which in turn means more power consumption and so on. So the RISC processors that can go into mobile phones and tablets and so on require less power and so on. But have a read of that, very interesting, and we'll talk more about that. Input devices, output devices, well, there we are, there's some nice images of them. And it talks about the different ones, from mouse, keyboard, trackball, some that you've seen before, microphone obviously, but then some others, 2D or 3D scanner and so on, interactive whiteboard we see in class. Then it goes on to output devices, standard ones, monitor and speaker, and then we're on to storage devices, random access memory, volatile memory that's switched off, and so on. Right, now I'm going to scoot through that. That's all chapter 1 here, and it just goes through. I'll talk about this as well, the units that are used and the different types of memory, because back into here now. So that's the textbook. There's also a revision guide that you might has some further information in it, but the specification you can just refer to once in a while, although that's my role really to go over that. But I know some of you will be interested to see what topics are coming up as well. This book certainly be using that. And then this is where the tasks are. So hardware workbook, this is an activity. So here is your task. You will have this under here, and if I click on it, it opens up a new tab with my workbook. Now just while it's loading that up, I can see, I'll just go back a tab. So you're going to open that. This is my class. There's 11 in this class, and there's another 18 or 19 in the other class as well. It says use the textbook pages 4 to 20. We've just been looking at to help with this section. Also use the PowerPoints, which you'll see teacher presentations just below, and the flash animations are also very useful to look at as well, as far as these, and they come together as quite a nice set of resources. So if I go to the textbook, it starts with topics covered in this book. Tick or just put something yes or a Y in there when you've done it and so on. All of these, you'll see all of these throughout here. So it talks about input devices, and throughout here then there's some tasks. So name the following and identify whether they're input or output. So here we are. Not a great image, but it's a monitor or visual display unit. It's an output device. A mouse is an input device, so we'd write that and so on. So you can see that with the task. It's got the von Neumann structure, and it's asking you to fill in the boxes with the number of input devices and output devices and so on, or the role of each. Fill in the blanks, says. So in our computer device, the computer is a device that can we'll see what it is, because it's the answers to that are in the presentation, but also in the textbook. And as we go through, it's throughout here, then there's a little bit of workbook. I've got access to this workbook as well. There's a bit here about ports, which you'll see in a little bit. There's a multiple choice, but I also have left the answers in the presentation as well. So this is your workbook here. I'm just going to close that. And if I now go to teacher presentations, so there's booklet presentation 1. I've converted it to a Google slide, so you can view it in Google. You don't need PowerPoint necessarily to use it. So this is our presentation, or this is the presentation that I would have used in class to introduce the topic. So it's worth having a read through and seeing, there we are, there's the images, and it tells you what to do. So that's the sort of thing that would have been up on the board. It says it's a device that can receive data, store data digitally, and so on. And I think that was in that fill the gaps element. There it's got input devices, it's got the output devices, it's got the processor. So again, it's the von Neumann structure again around the computer. It talks about input devices, and throughout there's a number of different things about reliability of computer systems. And then there's some extension as well. And if I go teacher's answers, you will see there's some of the answers for the questions that you will have seen in the workbook. Right, so that's booklet 1. If I go to booklet 2, just to show, doesn't take too long to load. So again, here's an image that you've seen in the textbook, but also in the presentation. So what's the purpose of a bus? The bus is the route that takes signals, whether it be the address, the bus that carries addresses, address number 1 or address number 99 in the RAM to get things from. The data bus carries the actual data, and the control bus carries the signals indicating what to do, or what command to do next. Here's ports and connectivity, and you saw this diagram again. So it says label the ports, and to help you with these sort of questions, further reading, so on. I'm now going to go to the Flash presentations. They're only small little programs, but it'll ask you to download them, so do download them. But if I go and have a view of them, so if I look at my input-output devices, Flash, so there they are. I'm just going to run through, and it shows input or output, tells me it's an output device. Input or output, well, all of these are input devices. So that's that one done. CPU, so if I run the animation, it shows me the different sections. Roll over the image, and it tells me all about the ALU, the arithmetic logic unit, on the right hand side, what the register is. And you can see down in this area here, an accumulator is a common example register. This is register using the ALU to store results of calculations. You've seen the accumulator when you were doing the Little Man computer. And that's CPU. And if I just scroll through, we'll go through fetch, execute cycle. It talks about fetch, decode, and execute. So fetch the command, decode what it wants you to do, and execute. Now it's going to say what each one does. So again, just a different way of seeing your the textbook. This one takes a little bit of moment, but it's really telling you, right, gigahertz, megahertz, kilohertz type processors. So this one can process much faster, this one very slow, and this one even slower. I'm saying very slow nowadays. Of course, many years ago, megahertz was more than enough. Multi-core, we saw this diagram, here we are. So this is single core, so there are 8 instructions coming through, 1, 2, 3, 4, they drop through, it takes them 3.5 seconds. Let's go to dual core, and you can see there's 2 cores now on the processor. 4 instructions go through one, 4 instructions go through the other. It takes 2 seconds. And then the quad core, 2 instructions, 2, 2, 2. So it's still 8 instructions, but they work in parallel, and so it's now down to 1.5 seconds as opposed to 3.5 seconds. So it's not exactly the maths of a processor, but it's showing you that it speeds up by using quad core and so on. Memory, and now it does ask you on here, although it didn't give you, it'll give you the right answers. Bottom left hand corner, answer to reveal answers. But have a look. Cache, memory within the CPU, it's very fast operating. So, oh, that's the one. I gave that explanation before. So I'm going to draw a line across. RAM is the main memory for data and programs. Yeah, that's the one. It's that one. And ROM is permanent method of storing. It's read-only memory, never gets deleted. And then I'm going to have flash memory is this one, permanent method of storing data once, so I say SD card or a USB stick and so on. And then the answers will come up and just show me those lines that I'll have done. Right, so there's memory and then there's graphic user interface as well. So it's worth having a look at those animations, just a different way of viewing the same work. And then I'll post further work on here then next week once the hardware workbook is done, and we'll move on to the next part of the specification, which if I get up to here, we'll talk about input output. There are past paper exam questions. Once we've gone through this, then we will be able to do some examination past paper questions, but also it means that whether we have to do it remotely or whether we do it in school, by the time if we're back in late June or July, then we can do past paper examinations in order to be awarded a grade for the end of the year. But keep in touch and advise me how it's going by email, but also fill out this workbook. You can download it to your user area, download it to your computer at home if you want, and then upload it after, or just work on it on Google Drive here. Alright, that will work. I'm pretty sure it works on most tablets, but it'll also certainly work on a laptop. You can also do it on your phone as well, access Google Drive, but yeah, and keep in touch.